Alright, so if they gave us a problem that said graph the equation f of x is equal to negative x squared plus 6x plus 2, and then justify and explain your work. So they just want us to explain why we are following the steps we are taking. First, we write the equation in standard form. Well, if you don't know, standard form is y is equal to ax squared plus bx plus c. That is standard form. So is it already written in that form for us? Yes. So I'm just going to rewrite my equation. Y is equal to negative x squared plus 6x plus 2. Now they want us to identify the constants, so we need to identify A, B, and C. They say A is negative 1. If A is negative 1, what's B? 6 is right. And C is 2. All right, then what we need to do is we need to find the vertex using that equation. So I'm going to write find the vertex. And we're going to remember, we're going to write this down in our notes later too, but this is a formula we use to find the h value of our vertex. Because remember, your vertex is hk. So this helps you find the h value of your vertex. This formula, the opposite of b over 2a. So if b is positive 6, the opposite of positive 6 is negative 6. They plugged in a negative 1 for a, simplified it in the calculator. All you would have to do is negative 6 over 2 times negative 1, and that's where they got the positive 3 from for your h value. So, justify, why do we do that? Because we were trying to find h. Now that we know what h is, we need to figure out what k is. Well, how can I do that? You can do that by substituting h into our original equation. So h is 3. And so I'm going to plug, anywhere I have an x, I'm going to plug in 3. So negative 3 squared plus 6 times 3 plus 2. And what this is doing is helping us find our vertex. So again, I put this in my calculator. It's important that you leave that negative on the outside, because if not, you're going to get a wrong answer. Ooh, I forgot my plus sign. That's important as well. And so we get f of 3 equals 11. Well, what does that mean? That's my y value now of my vertex. So I know my vertex is at 3, 11. Next, they tell us to find the axis of symmetry. I don't know if you remember or not, but the axis of symmetry is x equals h. Well, do we know what h is? Yeah. They're using this formula, but if we've already done all that work, there's no sense in that, is it? So x is equal to 3. So we're graphing this thing, so what they want us to do next is find our y-intercept. So find the y-intercept. Well, how could you find the y-intercept? When it's in standard form, it is actually very easy. The last number is going to be your y-intercept. So do you see how our y-intercept is 2? Your c value is going to be your y-intercept, okay? And then they graphed it for us. So we're going to be taking those steps today to just kind of find out information about each equation. So now I want you to turn to page 35. so we are actually going to look at the critique and explain. And it says, Jordan and Emery are rewriting the vertex form of a quadratic function, y is equal to 2 times x minus 4 squared plus 5 in the form of y is equal to ax squared plus bx plus c. That is actually in standard form. So they're converting it from vertex form to standard form. And they said, did Jordan rewrite the equation correctly? Did Emery? Because you see they have two different equations, right? So let's figure it out ourselves. Let's see if they wrote it correctly. So we've got 2 times x minus 4 squared plus 5. We said if it's squared, that means it is multiplied 2 times, right? And yesterday we FOILed the binomials, but first I'm going to distribute the 2. You could multiply the 2 binomials together first if you'd like. But I've got 2x minus 8 times x minus 4 plus 5. Now we can distribute. 2x times x is 2x squared. 2x times negative 4 is a negative 8x. Negative 8 times x is negative 8x. And negative 8 times negative 4 is a positive 32, and we bring down our plus 5. Combine any like terms together. So what I got for standard form was 2x squared minus 16x plus 37. So are either of them correct? Nope. Neither are correct. The answer is y is equal to 2x squared minus 16x plus 37. Alright, part B says, without rewriting the equation, how could you prove that Jordan or Emery's equation is not equivalent to the original? Well, what we could do to prove that they weren't equivalent to the original is you could set them equal to each other and check the graph, right, to see if they were the same. Alright, the next part says Casey rewrote the vertex form too. But look what he did. He said negative 4 plus 5 was equal to 1. That is true, but can you add within parentheses like that? Nope. So nope. Cannot add within parentheses. Alright, next page. Alright, so on this page it says, find the vertex of a quadratic function that is in standard form. Well, in order for us to do that, we have to figure out what a equals, Or if we want to rewrite it, A equals H equals K equals, right? So A is going to equal A, no matter what. You're going to see what I mean in just a second, hopefully. H, we're going to use this formula, negative B over 2A. And for K, we're going to use the formula of C minus H, or, excuse me, A times H squared. We're just going to use all these formulas to figure out, I don't know why. Alright, so if we look at our triad over here, we've got f of x is equal to x squared minus 8x plus 5. So let's see, what does a equal in the standard form of our equation? A equals 1, b equals negative 8, and c equals 5. Alright, so if we're writing it in vertex form, a equals a, so a is still going to equal 1. I don't know what h equals yet, and we'll figure out what k equals in just a second. So h, we take the negative b over 2a. So negative times negative, or the opposite of negative 8, so two negatives make it a positive, times, or over 2 times 1. So h equals, you want to put it in your calculator, h equals 4, yep. So k equals c minus a times h squared. So c is 5 minus a times h squared. So 5 minus 1 times 4 squared, not 9, 4 squared. And we get negative 11. So now I've got A, I've got H, and I've got K. So I can write it in vertex form if I needed, but they're just strictly asking me for the vertex only. So your vertex is what, 2 points? HK. So my vertex is 4, negative 11. Alright, now they tell us to graph a quadratic function in standard form. Use key features to graph the function f of x is equal to x squared minus 6 plus, or minus 1. So first thing I'm going to decide is what does a equal? 1. B equals negative 6, and C equals negative 1. Alright, so in order for me to graph this thing, what I have to do is I have to at least have my vertex and my y-intercept. So to find my vertex, I need to find h and I need to find k. So look, we're going to go back to these formulas up here. H is equal to the opposite of b over 2 times a. So that would be 3. K is negative 1 minus 1 times 3 squared. That would be negative 10. So that means I've got a vertex at 3, negative 10, right? My y-intercept I told you was always going to be your c value. So what is our c value? negative 1. So our y-intercept is going to be at 0, negative 1. So that I can actually plot my vertex and things on here, I'm going to go by 2's on my y-axis, but 1's on my x-axis. So my vertex is at 3, negative 10, so 1, 2, 3, 2, 4, 6, 8, 10. Got a y-intercept at 0, negative 1. So this y-intercept, do you see how it is at 0, but my vertex is at 3, right? And always on the parabola, what you have on one side, you have on the other. So that means I'm also going to have a point, because this one's at 3, or 0, negative 1. I'm going to also have a point at 1, 2, 3, 6, negative 1. Because what we have on one side, we have to have on the other. So my parabola is something like this. Alright, this next one's a word problem. It says a water balloon was thrown from a window. The height of the water balloon over time can be modeled by the function y is equal to negative 16x squared plus 160x plus 50. What was the maximum height of the water balloon after it was thrown? So the maximum is going to be like where your vertex is, right? And they want us to know basically what our vertex of this equation is. So to figure out what the maximum height, we have to first figure out what h and k equal. So h equals, well, hold on, I'm going to come over here and write what a equals, b equals c. So a equals negative 16, b equals 160, and c equals 50. So the opposite of b over 2 times a. Put that in your calculator, or somebody put it in the calculator for me. Five. Okay. So we know the x value of my vertex is 5. Found the y value of my vertex. I'll say c minus a negative 16 times 5 squared. We should get 450. Alright, so our question was, what was the maximum height of the water balloon after it was thrown? This is time, x is time, y is height. So what was the maximum height? Yep, 450 feet. That's a nice thing. Oh, it's not in the window. How long did it take for the water balloon to reach that maximum height? Yep. Everybody got all this? All right, example 4. It says, what is the correct equation of a parabola that passes through the points, and it gives us 3 points? I want us to actually do the example that was also in the book. And we've got, and it's the same directions. What is the equation of a parabola that passes through the points? The first point is negative 2, 32. So what we end up having to do, guys, is we have to put x and y in to this standard form of our equation, okay? You may be thinking, well, what do you mean? Well, this is x and this is y, correct? So we're going to say 32 is equal to a times negative 2 squared plus b times negative 2 plus c. We simplify this. So we're going to say 32 is equal to negative 2 squared is 4, so 4a. Negative 2 times b is just negative 2b plus c. So that's our first equation. We're going to do that for the next 2 ordered pairs. The next ordered pair is 1, 5. So wherever we have y, we're going to plug in 5. Wherever we have x, we're going to plug in 1. So 5 is equal to a times 1 squared plus b times 1 plus c. Simplify it. 5 is equal to a plus b plus c. And then our last ordered pair that this parabola passes through would be 3, 17. We're going to do the same thing. 17 is equal to a times 3 squared plus b times 3 plus c. So my answer here would be 17 is equal to 9a plus 3b plus c. Alright, so now what we have done here is we have set up what, and this is not example, we're going to go below where it says example 5. What we have done is we have set up a system of equations. So I'm going to rewrite it where my solution's at the end. So 4 minus 2b plus c equals 32. That's my first equation I got. My second equation I got was a plus b plus c is equal to 5. And my third equation I got was 9a plus 3b plus c is equal to 17. Here's where our calculator is going to come into play. We're going to go to second matrix, over to math, and we're going to find that RREF that we used last week. Or maybe this one. Second our second matrix, or the inverse button. And then remember, to get our columns and our rows, we just went to alpha zoom. Alpha zoom. Well, I've got 3 rows, so I'm going to make sure that's highlighted. But I've got 1, 2, 3, 4 columns. You may be wondering how I got that, because I didn't write it in a matrix, but that's 4, negative 2, 1, 32, 1, 1, 1, 5, 9, 3, 1, 17. That's just if you need to see where I'm getting these numbers from, okay? So I'm going to hit OK, and then I'm going to enter all those numbers. 4, negative 2, 1, 32, 1, 1, 1, 5, 9, 3, 1, 17. You hit enter. It gives you that identity matrix. Remember, we talked about they need to be in a diagonal, the ones. And then it tells you what A equals, what B equals, and what C equals. So A equals 3, B equals negative 6, C equals 8. So the standard form of this equation will be y is equal to 3x squared minus 6x plus 8. All that work for one equation. How do I put what? What part of the calculator? To the like RREF. Hit second. And then this button right here. Okay. It's right below math. And then you go, oh yeah, you go over to math, and then you go to RREF. You see that? And then to get this thing up here, alpha zoom, and then change your row. Alright, so let's take a look at this one. So I've got 2, negative 12. So negative 12 is equal to a times 2 squared plus b times 2 plus c. Simplify it, negative 12 is equal to 4a plus 2b plus c. My next point is negative 1, negative 15. So that would be negative 15 is equal to a times negative 1 squared plus b times negative 1 plus c. So negative 15 is equal to a minus b plus c. And my last point is negative 4, negative 90. So we've got negative 90 equal to a times negative 4 squared plus b times negative 4 plus c. So negative 90 is equal to 16a minus 4b plus c. Now we've got our three equations, don't we? So we can write our system. So my first equation is 4a plus 2b plus c is equal to negative 12. A minus b plus c is equal to negative 15. And 16a minus 4b plus c is equal to negative 90. If you write it as a matrix, that would be 4, 2, 1, negative 12, 1, negative 1, 1, negative 15, 16, negative 4, 1, and negative 90. So again, second inverse of x, we go down over to math. We found RREF. We hit enter. We hit alpha zoom. I have 3 rows and 4 columns, so I hit OK. And I just plug in my numbers. 4, 2, 1, negative 12, 1, negative 1, 1, negative 15, 16, negative 4, 1, negative 90. Tells me what A equals, what B equals, what C equals. So A equals negative 4, B equals 5, and C equals negative 6. So my answer for this would be y is equal to negative 4x squared plus 5x minus 6. Oh, sorry. There we go. And truthfully, it just dawned on me because of what we're about to do with this quadratic regression, we might can solve it a different way. Let's see. 2, negative 1, negative 4, negative 12, negative 15. Negative 90. Yep, you could solve it that way. So what I just did is I went to Stat, Edit. I know y'all use this sometimes in Algebra 1. And I just put in all the x values, 2, negative 1, negative 4. All my y values, negative 12, negative 15, negative 90. I know this is a quadratic because it is raised to the second power. So I go to Stat, Calc, and do y'all see where it says quad? That's what we choose. And it gave us our A, B, and C value, just like that. So that's much quicker, isn't it? But either way works. Alright, so this says a fan threw a souvenir football into the air from the top of the bleachers towards the bottom of the bleachers. The table shows the height of the football in feet above the ground at various times in seconds. If the football wasn't touched by anyone on its way to the ground, how long did it take the football to reach the ground after it was thrown? So, first of all, we got to figure out what our equation is. So we're going to use that stat button again. And truthfully, you don't have to put all of these points in there. You could just put 3 of them, but I am going to put all of them just to make sure. So I just went through and on that table I put it in stat. We're looking for a quadratic equation. So remember, when you calculate, you need to go to stat, calc, quadratic. Oh, I did the wrong thing. Stat, calc, quadratic. And it tells me that A equals negative 16, B equals 12, C equals 10. So my equation of the path of this football that was thrown would be y is equal to negative 16x squared plus 12x plus 10. Alright, but look, it says if the football wasn't touched by anyone on its way to the ground, about how long did it take the football to reach the ground after it was thrown? So basically, we have to know what our x value is when our height is 0, because if it touches the ground, it doesn't have any height, correct? So I need to know what my x value is when y is equal to 0. So 0 is equal to 16x squared plus 12x plus 10. You could factor it and figure out what x equals, or we can just do this. Put it in our calculator. Y equals negative 16x squared plus 12x plus 10. And what we are looking for is we are looking for our x-intercept, because y is equal to 0 at our x-intercept. So I'll look at my graph, and I know it's not going to be this negative one, correct? Because you can't have negative time. So it's going to have to be at least this positive one. So I'm going to hit second table, or is that no, second trace, sorry, and find this is what we call a 0. That's your x-intercept. So I'm going to make sure I'm over here by this correct x-intercept, and I'm on the left side of it. Now I'm on the right side, and look, it tells me that it is at 1.250. So what that means is it took it about 1.25 seconds to reach the ground after it was thrown.